Hello, we are here to present our project Store Sales Time Series Forecasting. So the problem statement is that we are given the sales of of different stores in the country Ecuador, which is a time series data set because we have sales for each and every day for different stores. The goal is to predict unit sales for thousands of items sold at the grocery store. The challenge here is to take into account other socio-economic factors affecting the sales, such as oil prices and other public holidays. Coming to the dataset description, the dataset contains one primary train file, which has basically all the records of sales of different stores. Other than that, we have three other auxiliary files, which provides us extra features such as the oil prices for the time series, and we have the holidays that are and the public holidays that are there during that time series. So this data is from 2013 to 2017. Uh, Coming to the exploratory data analysis of the dataset, so you can see that the data is not always linear. So there are spikes seen in the data, and this suggests that there is some fluctuation within the data. Other than that, over the week, the sales is recorded highest for Saturday and Sunday. Similarly, for certain months, like during the holiday season, the sales increases. Uh, we can also see that as the oil prices dips, there is an increase in the sales, which suggests us that there is a correlation between the sales in the store as well as the oil prices. Uh, so to accommodate all these factors, we did some feature extraction. We extracted the time series features such as the day, month, and month, a week, the day of the week, and the year, and we extracted this into categorical variables and numerical variables. We also took into account the oil prices for the dates that we have, and we are because it seems like like an important factor for which affects the sales. Evaluation metrics. Since this is a Kaggle competition, the baseline is set using the root mean squared error. So we have taken the same evaluation metric for that. So this gives us a quantitative prediction as to how correct the model predicts the sales. Coming to the baseline model, we have chosen linear regression as our baseline model because usually the sales data set tend to perform better with linear regression, and there is a linear trend that was seen. So we took linear regression as our evaluation metric, as our base model. Coming to the linear regression performance, you can see that on the graph between the actual and the predicted sales, that the linear regression performs fairly well, but it fails to take into account the spikes that we see or that the growing trend that happens irregularly. So the RMSE value that we achieved on this was 993.91. So to make a better model for this dataset, we came up with the multi-layer perceptron model. Uh, we designed MLP with 14 input nodes, three hidden layers, and an output layer with linear activation function because we want the predicted values. The model was trained for 50 epochs with a batch size of 1024. Coming to the results of the model, so you can see that in the total accuracy was a total predicted cells, that this performs better as compared to the linear regression model, as this is fairly able to accommodate for the spikes seen in the data. With this, we were able to achieve the RMSE value of 440.31, which is almost like 50% reduction in the error observed. Coming to the conclusion, so we used linear regression as our base model and came up with MLP model to better suit the data, and we were able to take into account the spikes that were seen in the data. So furthermore, if to further accommodate like the spikes that were seen which were not predicted correctly by MLP, we would have to use additional layers or a LSTM model to better understand the sequential data. Thank you.